Morning, folks. How's it going? Or good afternoon if you're in fifth or sixth period. All right. Hey, so today's going to be great. Obviously, I'm not here. Y'all's be good for Miss Lewis. I'd appreciate that. So here's what we're going to do today. Okay. The idea is I want y'all to do part of the lesson, okay, in your workbooks. Okay. And then there is a review assignment that y'all are going to do on Canvas. You will see it at the If you scroll down my homepage to the week at a glance, you will see a Unit 3 review assignment that is next to Monday, okay? Obviously, if you've clicked the link for this video, you have seen the assignment below it, okay? So there is this video you need to watch, then you need to complete the Unit 3 review assignment that's in class, and then you have homework. If you finish the two other things, you can get started on the 3.14 practice problems, okay? But in this video, pretty much what I'm going to talk about is a few things from today's lesson, okay? Just a few items that I really want y'all to capitalize on, okay? So, first of all, this starter kind of directly addresses the I can statement for today. Our I can statement is I can write linear equations to reason about real-world situations. And we've got two different real-world situations here, okay? So, first of all, we've worked with slope-intercept form a lot this week. Slope-intercept form being y equals mx plus b, where m is the slope and b is the y-intercept. All right, some equations will look like that. Some will not. Okay, so if we're looking here, okay, let me actually get my pointer out. All right, let's look at number 1 on the starter. It says grapes cost $2.39 per pound. Bananas cost 59 cents per pound. And we have a total of $15 to spend on grapes, which we'll use G as that variable, and bananas, which we'll use B. Okay? Now, there's kind of two rates here. Okay? There's the cost per grape and the cost per banana. And then we have something else. We have a total. Okay? This equation is not going to be in slope-intercept form. First of all, we have two rates. Okay, the rates of the grapes, the cost of the bananas. And we also have a total. Okay, so we've got the total of the grapes and bananas will equal this thing. All right, so this is going to be in a bit of a different format, but y'all can make sense of this. If you can tell me how much, or if 2 pounds of grapes and 2 pounds of bananas will get us $15, you can write an equation for this. Pretty much when you're doing that, you're trying to figure out the pounds of grapes multiplied by 2.39 is going to give us the cost of the grapes. To get the cost of the bananas, what are you going to do? You're going to do our bananas times 0.59 to get the cost of the bananas. All right? And if this is going to equal $15, we add those up, and if it's equal to 15, then we know that amount of grapes and that amount of bananas will suffice this need for it to be $15. Okay, and you can already see right there we've got an equation. Okay, if you got that equation, fantastic, good work. Okay, if you didn't, that's okay. We'll have some more opportunities to practice that. All right, let's look at number 2. I want y'all to start this one without me. Okay, so pause the video, give it a go. Okay, if you haven't paused the video yet, do that. Okay, if you have paused the video, listen up. So a savings account has $50 in it at the start of the year. Okay, and $20 is deposited each week. There's that clue word each. Okay, and $50 was just at the start of the year, one time. All right, after X amount of weeks, there are Y dollars in the account. Okay, so a couple things about this. This equation tells us how much this person started with at the start of the year, $50, okay? It also tells us a rate, $20 is deposited each week. Okay, sounds like a slope and a y-intercept, all right? So to write this, we're gonna use slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept, all right? It also makes sense if we're just reasoning through this equation. So y is the amount of dollars in the account. Okay, that's what we're calculating. That's our total in the account. To do that, we know this person's depositing $20 each week. So 20 times the number of weeks will tell us how much money we have. $20 each week, 20 times the number of weeks. Okay? We cannot forget that this person started with $50. So whatever $20 per week is, we've got to add $50 to that. Ta-da! And we've got our equation. Okay, if you got both those equations, doing very, very well. Great job. If you didn't, we've got some work to do, okay? We've been working on slope-intercept form for about a week and a half now, a few weeks, okay? We got to nail that one down. All right, cool. So let's go on to one of the activities, okay? I want Charles to try, we're just going to go over one of the activities, all right? And it's going to be fabulous fish. Fabulous. All right, we should bring back our fishy friend. All right, Phyllis. Too bad Phyllis isn't here right now. So, oh, just kidding. It looks more like a bow tie. But anyway, so we've got a Phyllis, right? Okay, Phyllis doesn't have the eye patch. There, I got better. Phyllis doesn't like this question because it talks about eating fish. So we probably want Phyllis to have some 6 headphones so Phyllis can't hear that, right? We want Phyllis to stay happy. There we go. What's up, Phyllis? All right. So here's the deal with fabulous fish. Give it a go. I want y'all to do, let's say, okay. I want y'all to do 1 through 5. Okay. Pause the video. Give that a go. How much time have I been talking for? 6 minutes. Oh, that's chill. That's super chill. All right, 6 minutes video. That's great. This will probably end up being what, like 10 minutes? 10-minute video? And they're working in it. Show 10 minutes plus like 5 minutes of student work. 15 plus those 2 assignments. Oh man, crushing it. All right. If you're hearing me rant, pause the video. Do the work. Okay. If you did the work, great. You're on pause the video. Let me talk to you about it. Okay. So let me go through how I did this, all right? So here we've got fabulous fish market, right? Obviously, why Phyllis is here. Okay, orders tilapia. Now the tilapia costs $3 per pound. That's tilapia. Salmon costs $5 per pound. I'm going to write salmon here. It's up here, but if I underline it, it's just too close to the other one. I like to separate things. The market budgets $210 to spend on this order each day. Okay, great. So in a day, we are able to spend $210. All right. So what are 5 different combinations of tilapia that the market can order? Well, let's figure that out. Okay, let's do one. So tilapia is $3 per pound. The other one's $5 per pound. Oh my gosh, so we could really nail this. Okay, for example, if I do 0, let's say tilapia and salmon, we only need 3 combinations. So I don't need a line that big. All right, and I want to be able to show you all the work. Okay, so let's say I ordered 0 tilapia. Okay, the salmon costs $5 per pound, and we get 210. So salmon times 5 needs to equal 210 because we have 0 tilapia. Okay, this is a pretty easy one to solve, right? 210 divided by 5. Oh my gosh, that's 20, 40, 42. Okay, I'm going to check my calculator just in case. All right, 210 divided by 5 is 42. Freaking genius, yes. All right, love it. Anyway, so 42 would be the amount of salmon. Okay, let's try something a little harder. Okay, let's do 10 pounds of tilapia. 10 pounds of tilapia would cost me $30, right? Because 10 times 3 is 30, right? And now we've got our salmon times 5 needs to equal 210. So I could solve this. What I probably want to do is subtract 30 from 210. Okay? Now we've got our amount, our pounds of salmon times 5 is going to equal 190. All right? We just made this problem not too difficult, right? All we need to do is divide 5 from 190. Okay? And it'll be 40. No, it won't. It'll be 38. Right? Let's double check that. 190 divided by 5. equals 38. Let's go. All right, 30 and 38 pounds of salmon. Why does that seem wrong? Oh, here's why it seems wrong, because this was 10 pounds. Okay, not 30. All right, there we go. So we've got 10 and 38. Let's do one more. I don't know what y'all's did, but if you plug what you got into an equation and it's true, then you'll be good. And I'll tell y'all a little bit about the equation. Okay? It might be easier to write the equation first if you're defining variables and writing an equation representing the relationship. Okay? So before I do the next one, let's actually talk about the equation. All right, so we've got the amount of salmon and the amount of tilapia. Okay? The tilapia costs $3 per pound, and the salmon costs $5 per pound. So to get the cost of tilapia, you're multiplying 3 times the pounds. To get the cost of the salmon, you're doing 5 times the cost of the salmon. All right? Add those together, and it should equal 210. Okay, that's your equation. All right? So if you want to figure out how much tilapia we need, if we have 0 pounds of salmon, well, 5 times 0, we don't know the tilapia, so we'll do 3t plus 5 times 0 equals 210. If you solve the equation this way, it's not too bad. 5 times 0 is 0, right? So we end up with 3t plus 0 equals 210. Or just 3t equals 210. Now, what is 210 divided by 3? I think it's 70. Let's see. It was. We divide 210 by 3. We get t equals 70. So if we have 0 salmon, we have 70 pounds of tilapia. Fantastic. We've got those 3 points. All right? I'm going to keep that work up there. If we sketch a graph of the relationship, label our axes, what we're going to end up having is a couple points, right? Salmon, let's do salmon on the x, tilapia on the y, because why not? Okay. Your graph should end up with a negative slope. And we can see that this is an indirect relationship up here, right? As tilapia is increasing, it's going up, the salmon is decreasing or going down. We can also see that on the graph. Salmon, if we graph 42 and 0, right, that would be this point here. Okay, that's a point on the graph. 70, I don't know, I'll put 70 here. Okay, and 0 pounds of salmon, 70 pounds of tilapia. We have there. And somewhere in the middle, we have our point where it is 38. 38 right here. And 70, I'm assuming that's 1, 2, 3, 4, 5, 6, 7. So that would be 10. We'd have another point here. Okay? This is going to look a little curved, but our line, we can see, is going to be a negative slope. All right? So you should have something like that. On your graph, plot and label the combinations A through F. Okay, so you can plot those for the sake of time of the video. We're going to go on to number 5. All right, so 2 ways we can tell if a pair of numbers is a solution to the equation. All right, let's write our equation down real quick, and then after this, y'all can get on to the review assignment, the Unit 3 review assignment, and if you finish that, you can do the homework for tonight. Okay, so, oh snap. That's not actually the bell, just a heads up. I think that's going to mess a bunch of people up. Some people are going to think that's the bell. All right, so we've got our equation, 3t, so capital T, plus 5s equals 210. Okay? 2 ways you can tell a pair of numbers is a solution to an equation. Number 1, if it's on the graph, okay? Look at this graph. This point here, 0, 70. Sorry, 70, 0. Okay? That is on our graph. That must be a solution to the equation. Okay? That's one way we can tell. If a point is on the line of an equation, then that point is a solution to the equation. Also not an actual bell. It's just a bell in my world, in the video world, okay? You're in the real world. I'm just on the computer. All right? Anyway, so first way to tell is if the point's on the graph. Okay? If a pair of numbers is an xy coordinate that is on your graph, it's a solution to the equation. Okay? The other way to tell is if it makes the equation true. If you do 3 times your t, let's say we had 4 and 5, right? 3 times 4 plus 5 times 5 equals 210. Let's try it out. 3 times 4 is 12, plus 5 times 5 is 25, equals 210. You already know, right? 25 plus 12 is 37, right? That does not equal 210. Nope, that is not a solution, okay? Because it did not make the equation true. If a coordinate makes the equation true, when you substitute it in.
Students and staff, we are in a shelter in place. If you are outside the building, return to the building for your portable classroom. If you are outside the building, return to the building for your portable classroom.
All right, so check this out. It's not. This is me.
Attention
Oh my
students and
goodness.
staff, we are in a shelter in place.
So what I'm going to do is just end the video because I think y'all's understand. All right? So
if you are outside the building, return to the building for your portable classroom.
I really wish I could focus without this voice. But anyway, so as I said, this is not a solution. If the coordinate does make the equation true, it is a solution. All right, folks, if you've done that activity, you are good to go. Go ahead and work on the review assignment and then work on the practice problems for today. All right, have a great day, y'alls. Bye-bye. I'm curious if you can tell when I was filming this video based on the interruptions. Okay, have a good day. See y'all's Tuesday.